In this video we're going to look at the Marshall DSL 2000 with bias problem, and we're going to try and apply the Doctor Tube stable bias kit and see how we get on. I've done one of these before and it was successful. It wasn't 100% successful, but it was an improvement, and I think on this amp we'll get a better result. So if you buy the kit, you get a bunch of parts. It takes about half an hour to put it together, solder it up, and you end up with something like this. I'm going to fit that in now and see how we go. With bias drift problem, so I'm going to try and give you a demo of that and a possible fix. So see the amp is upside down here on the cradle. See the 4 valves there. I'm going to be measuring bias on these two guys. Here's 2 meters. Temperature on the circuit board, anode voltage here, and be keeping an eye on the time. So I'm going to set the camera up and we're going to hopefully get some interesting readings. So the first thing you need to do is to remove the amp from the chassis, which we've already done, as you can see. I think the installation instructions are very much aimed at a professional technician, so there's no talk here of discharging the amp, which is should always be checked. On this amp the voltage discharges safely normally within a couple of minutes, and I've just been checking that and it's about 2 volts now, so it's safe to proceed. So let's make a start. And the first thing we're going to do is we're going to remove the circuit boards, I think. Remove the main printed circuit board from the chassis, so we'll get ahead with that. So the first step is to remove this sort of rear connector board to get the access. So you just need to remove all the nuts from the back and this board will come out. So you remove that rear board. Now the DSLs are held together with lots of these interconnect wires, and it's a good idea to either make a note of all the different connects or mark them up in some way so you can put the amp back together easily. Okay, now taking that out, next thing to do is to remove the valves. I use one of these little boxes to keep things in order, so remember where things are, and I like to do that. So I just keep things in the same place, and then when I put it back together it's pretty easy to figure it all out. So we can remove all these valves, and we need to then remove these screws here to take this cover plate off. Just makes life a little easier, and all these screws here securing the valve holders in it, so we can get the PCB off. Okay, so I'm going to work away on that, get that done. Okay, so there are 6 small, what look like M3 screws here. They've all been removed, and then there's 8 what look like self-tappers, probably M4 or something like that, all removed. All the valves are out. So this now lifts off, and we'll flip the amp back over now and work on the inside. Okay, so I've flipped over. I've actually reversed it as well to bring the rear panel facing me now. This makes it a little bit easier, I think. And the PCB, there's a couple of things to note actually. The PCB is secured by probably about half a dozen screws here and here, and there are standoffs behind them, plastic nylon standoffs that hold the board into the this sort of chassis cover, if you like. So we need to remove that, and once we've done that we should be able to access the board quite nicely. Now I think one thing to note is that on these bias problem boards they always seem to have this sort of pale green colour. The camera picks that out nicely, and the ones that seem to be better are much more dark green, like a bottle green, like the colour of this drill, so much more like that colour. So I think that is kind of an indicator, and this one is also from 2000 and 2002 the ones. I think those are the years I see most from. Okay, let's get that board out. Okay, the next step that we have to do is to we're going to disconnect pin 5, which is this guy here. So don't forget, this is pin 1 at the top on this amp. If you look at the side of the sockets, you can see pin 1 here. So that's kind of facing directly toward the camera. That's that one. Get on the screen. So that's 1, 2, 3, 4, 5. So it's kind of the one at the end here. Okay, and there's 4 of them. We need to desolder those, and then we're going to drill out the PCB so that we're disconnecting the grid. That's the control grid. We're going to disconnect that from the circuit, and then we're going to run wires directly so we completely bypass the PCB material. That's the theory. Okay, so I'm going to get my soldering iron warmed up and take care of that. Okay, so we've removed the solder now around the pins of pin 5. So if you look at this one here, for example, pin is moving fairly well. And what's going to happen next is we're going to drill that out using this special drill bit that they supply, which is like a little sort of hollow drill bit, and it has so get in there close. It's got just enough room for the pin to fit around it, and it will goes right on top of the pin like that. And it will whiz through and remove all that PCB material, leave the pin there on its own. So yeah, nice and simple. So we'll give that a go. So let's try that again. What's nice about this, does a really nice, neat hole. They do say you can use a Dremel. I do have a Dremel, but I don't think it's as nice as this. And what we must ensure is there's no little bits of copper left over, so we're going to give that a good clean out and look under the microscope. Okay, so we've done the cutting out the holes there. Let's have a little look. Let's try and see some light on those. And as you can see, some little whispers of fiberglass material. Probably a good idea to epoxy those down to seal them up, otherwise they'll be absorbing more moisture. So we'll try and do that as well. Okay, we're going to look at the instructions again and see what we've got to do next. So it says remove the 2 electrolytic capacitors C29, C30 or C3637 from the main PCB. Oh, which ones are they then? Ooh, okay. Okay, these are the guys here, I think. 3637. Yeah, these 2 little here. So we've now wired up the Dr. Tube kit and fitted the board on the channel, so it's kind of steady there. We left a gap here for that little W3 connector, and the cables are tucked in around just to kind of keep them from moving around too much. I think I'll probably cable tie these once everything's kind of set up nicely. So we just put a nice loop around the pin and then solder around that and make sure there's no contact with the circuit board. On this one, V5, I think, yeah, V5, this little track was sort of, I felt, has a little bit of whisper of copper traces still showing, so I've got a Stanley knife and cut that out just in case. And then we're wrapped around here, so this is the bias feed, I think, coming in, and, oh sorry, this is, yeah, that's the bias feed. So these are just wrapped around these resistors here, R2 and R3, I think that is. Yeah. Alright. Yeah. Okay, so it looks okay. I think we're kind of getting ready to fire this up now. I'm just going to check anything else. So solder the wires, connect the cable between con 2. Okay, so that's this one here. So that's basically putting it back in the amp and connecting up to the bias PCB. So I'll get on with that and get ready for testing it. Okay, getting ready to fire this up now. Just want to show the sort of finished piece of work really. So we've got the bias kit here, stuck down. There's wires feeding the valves here, the grid control grids, the various valves. And you've got the jumper cables, so that the adjusters continue to work as normal. So in this situation, a lot of surgery, a lot of possibilities for miswiring. You need to be aware of that. And so whenever I'm doing something like this, I would always fire it up for the first time using a dim light bulb. And if you don't know what that is, look it up. It's a sort of current limiting safety device really, that in the event of anything being completely wrong, it will limit damage to the amp to pretty much kind of like a fuse that doesn't blow, but it just sort of stops any power from coming through. So we'll use that, and hopefully we won't need it, but it's a good safety precaution. Okay, so let's get ready to do that. Okay, so we're about to fire this up. So you can see, I don't know if you can see, yeah, you can see that. This is my dim light bulb. I've got several bulbs here, various combinations. Two top ones are 100 watts, I think, and the last one, bottom one's a 60 watt. So it's pretty useful for kind of bigger amps, but just with one on, sorry, just with this amp, I'm just going to put it on with one of those bulbs illuminated and see what happens then. You'll see it will glow faintly, hopefully. If it glows brightly, then it's there's a wiring error. So hopefully you can see that just sort of like it's just a glow. So that's a really good sign, because that tells us that we've certainly done all the heater wiring okay, and probably the low voltage as well. Next step is when we put it on play mode, and because that's the high voltage, that is also a little bit risky. But I do lots of these. I'm pretty confident that I know what I'm doing. So when I double check my wiring, so let's see what happens. So you could see there was a bit of a flash over here, and that's just the surge of current as you turn on. And if we see over here, so we're measuring, it's the plate voltage here, 327. That's dropped because the dim bulb is limiting the current, and so the voltage can't get to where it wants to be. These are the bias voltages. So on the valves on the left hand side, again 40, and ones on the right hand side 27. So obviously that will probably need adjusting. Let's just increase the current limit to the maximum. There's still a little voltage drop because this plate voltage probably should be more like 460 or 470. So not too worried about that for now. But obviously when we bias it up, probably want it to be on the correct voltage. So I'm just going to probe around here, just make sure there's nothing to worry about there. That looks good. Okay. So I'm just going to pause there for a second and just make sure the voltage is, the current limit's turned off now. Okay, so we're now running at full voltage, so it's 474 on the anode, which is, yeah, it's great. And I've tried to stabilise the bias current. Bias current over a 1 ohm resistor is giving us the current reading here, but expressed as a voltage, so 76 milliamps. So I think what we'll do now, I assume the amp is sounding good. Let's have a listen. Sounds okay. So what we're going to do, I'm going to set up a hyperlapse and see how this bias, if the bias drift is restored or to what extent it's still persisting. Okay. So back the amp, I have now changed out the valves because I was a little bit unhappy with the old ones for two reasons really. There was a little bit of movement on the bias, and over a period of time, over I don't know 30 or 40 minutes, it did drift up a tiny bit, but not clearly. The Doctor tube fix has worked. But if you just look here, you see these are the new valves in JJ's. This is the old one as a JJ, and you can see how the writing of the JJ has sort of gone dark. It's actually faded, and that's because those tubes have overheated severely, and the red is just sort of discoloured. So I think it's a bit risky to continue using those, especially for this client. I want the amp to be kind of a very reliable, long-running one. So yeah, so that's it. It's all wrapped up. Leave a comment if you enjoyed the video. If you want to ask any questions, feel free. That's great. Bye.